Thanks everyone for coming to a very special occasion today. I'm Rod Smernick. My connection to this event is that I was actually Malcolm's last student while he was here. And I guess I've also worked in this area of organic matter. Before I start, there's a couple of apologies. Jeff Fincher and Roger Lee were unable to come due to other commitments, and also David Chiddlebrah sent an apology. He's overseas at the moment. I'll just read out what he said. Thank you very much for the invitation to this significant event. I'll be overseas on that date. It's with much regret, having worked with Malcolm for many years, that I'll miss the event. Judy Tisdall and I shared an office and lab at the time she was undertaking the work, as I was also undertaking my PhD at the time under Malcolm Oades' supervision. Judy and I had many fruitful conversations. I was a direct witness to the work. Okay, so as I said, a very special occasion, special enough for me to be wearing a collared shirt and shiny shoes, which all of you would know is pretty rare. What we're here for is a talk by the authors, Judy and Malcolm, on this paper. So what you may be asking yourself is, firstly, what is a landmark paper? This is something that the European Journal of Soil Science has initiated this year. So the European Journal of Soil Science, one of the most prestigious soil science journals, leading soil science journals, decided this year to go back through all their issues and identify the papers that have had the greatest impact over the years. And the first one that they chose was actually this paper. So indeed, a very special paper, the most special soil science paper, we might say. Next thing you might be asking is, if you're not soil science, is what are water stable aggregates, given the topic of the talk. And you're lucky that I happen to be talking about water stable aggregates to the second years just on Monday in my lectures. So I'll show you what I showed them. Now, I'll pass these soils around as I do in the second year lectures as well. So what I have here are two soils. They're both from here at the Oades, one from the Arboretum and one from the wheat fallow trial, or what's left of it. And the point is, we've got some aggregates, some soil aggregates, and if I pop an aggregate of the wheat fallow trial, the Arboretum, and that's not a rock, I assure you. From the Arboretum, you can see absolutely nothing happens. The aggregates are water stable. And on the other hand, if I do the same thing, and these soils are basically the same, or they were the same 7 years ago. So if I pop that in, we should see, and hopefully you'll be seeing that aggregate is actually falling apart due to slaking. And these soils, in terms of their mineralogy, are exactly the same. The difference between them is the amount of organic matter and the type of organic matter, and the way that that's interacting with the soil minerals. Doing its job there, falling apart. You can see it very nicely here, it doesn't come up so well there. Okay, so that's what water stable aggregates are, and by the end of today you'll know a hell of a lot more about them. And finally, you'll be asking, who are Tisdall and Oades? So, the format of this is that Malcolm and then Judy are going to give their perspectives, and then I'll give a perspective afterwards. So just a quick introduction. Judy Tisdall graduated with a BAg Sci from University of Melbourne, a Master of Ag Science from La Trobe University. She worked as an industrial microbiologist for a while at Kraft Foods, and then joined the Institute of Sustainable Irrigated Agriculture at Tatura in Victoria in 1968 as a soil scientist. She came to the University of Adelaide in the late 1970s to do a PhD under the supervision of Malcolm Oades, where she did the research that led to this landmark paper. She then went back to Tura. She was actually employed there the whole time, worked for a while, and then moved to La Trobe University in 1991 as a lecturer in viticultural science. Apart from her work on organic matter and water-stable aggregates, Judy has worked on many practical aspects of soil science and agricultural science, including the development of raised bed systems for both Australian and Indonesian farming systems. Until very recently, she was a senior lecturer in the Department of Agricultural Science at La Trobe University. She's now retired, but is still working, as many academics do. Now, Judy's going to talk second, so I'll introduce Malcolm first. Malcolm Oades was graduated with a Bachelor of Science from the University of Leeds in the UK in 1959 and gained a PhD from the same institution in 1962, which by my calculations makes it 3 years, which is, I would have thought, pretty good in those times, considering it took me 5. A lot later. Following a short stint as an assistant lecturer at Queen's University of Belfast, he took up a position as lecturer in soil science at the University of Adelaide in 1963, and he remained here until he retired in 2002. During his time, he held many positions here, including head of the Soil Science Department, Dean of the Faculty of Agricultural and Natural Resource Sciences, and Director of the Waite Agricultural Research Institute. He's got a list of awards as long as your arm, and a list of publications as long as your leg. I won't go through all of those, but the most important publication, or the most impactful, according to European Journal of Soil Science anyway, is this one. So I'll leave it to Malcolm to tell you about it.
Thanks, Ron. Oh, that's better. It's nice to see everyone here. And I'm going to do something that I said I would never do. I've listened to retired people give out-of-date talks, and I vowed that I would never do it. And yet, here I am. Somebody must be to blame. I guess it's Judy Tisdall. This day was brought about by the landmark paper, as Ron has outlined, and this is a histogram of the citations of that paper since 1982. And you can see the citations have been going up year by year, which is quite surprising. So we're looking at 2010, we're looking at about 100 citations for the year. That's quite pleasing. Anyway, I'm chuffed about it. But that's the reason we're here. That's in the introduction to the landmark paper by the various sub-editors of the journal. Now, Judy reminded me that when we first tried to publish this review, which is a review where we put together everything we knew, particularly from Judy's work, but everything else that she could find at that time. The editor didn't like it, and he had to be bullied a little, and I can't remember what I said to him. Somebody suggested it was quite curt. But there was a reason. In those days, in the 70s and 80s, soil science was dominated by physicists and chemists and physical chemists. And biology rarely got a look in. Even though people realised that organic matter was important, there was almost no biology going on in soil science, and certainly very little with respect to aggregation. Now, I don't intend to go into the details of what's in the review, but what I'd like to do is to reflect a little on that period which is what the editor of the journal asked us to do. What was the problem in those days? It was cropping systems that were leading to serious erosion. And everyone knows the causes: clearing of vegetation, wind erosion, rapid wetting, raindrop impact, and multiple tillage and fallows. That whole combination turned out to be a disaster for a number of soils. At that time, the scientific knowledge was headed up by X-ray diffraction and an understanding of clay mineralogy and what clay minerals were in what soils. Electron microscopy was coming into its own, and surface chemistry was quite dominant in publications during that period. We learned all about clay plates, domains. We learned about dispersion, coagulation, swelling, cracking clays, but very little about aggregation as Ron just defined it. There was a good deal of interest in organic matter, the chemistry of. That was the time when plant materials were separated out as a light fraction. They could be separated from the minerals and floated off. There was a good deal of interest in polysaccharides because sodium periodate had been used as a selective oxidant and shown to be involved in stabilizing aggregates. Some of us spent years playing around with gas liquid chromatography and saw polysaccharides. And then, of course, there were the magic cubic acids, which was the rest of it, which couldn't be defined and still hasn't been, but now seems to be part of history. We learned about clay dispersion. We knew about sodium and electrolyte concentration. And we had things like the Emerson dispersion test. Some of you will know that Bill Emerson passed away not too long ago. But he was a physicist from Rothamsted who was involved in clay dispersion and models of how clay flocculants interacted with sand particles. And we had all this information, and we also had long-term trials. And these long-term trials, in both cases, happened to be on red-brown earths developed on alluvial soils, and they were loams. There were trials at Tatura and Shepperton, which Judy sampled, and of course the long-term trials at the Oades, which were also sampled. What Judy did was to collect all this information, and out of it came a very good correlation between the carbon content of soils and years under pasture. So there was a nice positive relationship, and the negative, the negative relationship was between tillage and fallows with no organic inputs. And I think everyone knows now that no-till, stubble retention, no burning, and all that is part of modern agriculture. The other thing was a good relationship between carbon content and stable aggregation. But there were exceptions. And the exceptions turned out to be soils developed on basalt or volcanic ash, or a number of calcareous soils, where other agents other than organic materials were involved in stabilizing aggregates. Now, I've got a title here that says, "What is aggregation?" And we've already had a demonstration. When I was 10 years old, my father told me about friable soils. Does everybody know what friable soils are? Silence. They're not recommended for breakfast. But a friable soil is a soil which crumbles easily and gives rise to a seedbed. And the seedbed is something with aggregates of the right sort of size, measured in millimetres or maybe a centimetre or so, where you've got good aeration, you've got good water infiltration, and you've got the right sort of environment for growing roots and seedlings. So that's what the friable soil is. It's a little bit different from aggregation, but not quite the same. Now, aggregate stability is quite different from the pedologist's description of soil structure, as you might do in a profile. In those days, we had field texture, which you do with your fingers. You guys still do it or not? I'm not sure. Still done. Okay. And then, of course, there's mechanical analysis to back that up, where you oxidize all the organic matter and disperse everything with an amount of energy. And there are a whole range of dispersion tests. I think they're still going on, with different amounts of energy, which allow you to describe the stability of different soils. One of the things you always have to be aware of when you're looking at aggregation is the scale at which you're making your investigations, because they go from submicron right through the range up to almost a metre. Somewhere on this campus there is a nice photograph of a large French clod taken in a field in France, and this clod was almost a metre large, and that's the